So in part 2 we ended talking about different kinds of imaging techniques or scans of the brain. So an EEG records the activity. CT or a computerized tomography scan takes an image, which is a still shot, similar to x-rays, which it uses x-rays, but cross-sectional and multi-angle sections. And the magnetic resonance imaging, which is an MRI, also takes still shots similar to CT, but using the magnetic field and the radio waves. Alright, so here you can see a picture of a CT scan, what it would look like. You would be moved in and out of the imaging system there. You can see in and out that circular system, and then you would get an image like that you can see on the screen. And here is an image, a cross-section of the brain. You can see the eye is in the nasal cavity there. Alright, here's some pictures of MRIs. It's a little different. You can see how they're very detailed in color here. If you have had an MRI before, you know that when you get into this machine here, it's very loud. And it's loud because it's sending those that magnetic field through these coils, and just the process of doing that's very loud. So they give you those like headphones, and they might play music, but usually you can still hear it over. It's very, very loud. And if you move at all, they have to start over and redo the MRI. So MRI images. Alright, so another way to, now this is a little different. So we had an EEG which does brain activity. We've got the scans, the CT and the MRI. Now we have these techniques where we can observe the brain. Similar, it's like we combined imaging and activity. And so with the PET scan, you can observe the brain and observe the functions. And so it's kind of seeing the brain and seeing how it functions at the same time. So very useful and very helpful. So what the PET scan does, it stands for positron emission tomography, and it works in a way where they will inject radioactive tracers, which is just radioactive glucose or radioactive sugars, into a vein in your arm, and it'll go into your bloodstream, and it will pool and collect in places that a lot of glucose is being used or where there's activity happening. And so then the scanner will pick up where the activity is and will be able to image and observe that area where the activity is. And so this will also allow for doctors to check for diseases and just normal functioning, to track normal functioning. So that's a PET scan. An fMRI will also detect activity, but will detect it through blood flow and can detect where there's heightened blood flow in areas of the brain. And so again, it's doing the similar thing, observing activity, where you can see the brain as it is functioning, and you can see the activity happening. EEG will show you brain waves. CT and MRI will give you a still shot, and then the PET and the fMRI with a functional MRI will show how the brain functions. So here is a picture of a PET scan. fMRI is here. Alright, so wrapping up. So we've moved all the way through to how we learn about the brain today in modern times. And so this is what we got. So we can learn about the brain by removing a part to see how it affects behavior. We can learn about the brain through case studies, people who have suffered brain damage like Phineas Gage or Ton. We can learn about the brain through stimulation and through recording brain activity or getting brain scans. So that's it. And next we'll talk about parts of the brain.